Unit circle time, y'all. Best day of the year. All right, I'm going to teach you guys how to derive this from nothing because they're not going to give it to you. And even on page 22, we're not even going to be given the radians for it. You're going to get nothing on this, okay? But you need to know it. So the first thing I always do is I'm going to label my angles, okay? Now here's one thing I'm going to tell you. Each big chunk is 30 degrees. Each little chunk is 15 degrees. So we can find it pretty easily then. Because if that's 30 degrees, what's this one going to be? What's 30 plus 15? 45 degrees. What's 45 plus 15? 60. What's 60 plus 30? 90. Right? This right here, I'm going to put these on the line to help us. This would have been 0 degrees, and this would have been 360, right? I don't know how well this is showing up. What?
Yeah, the way basically.
What? Move, T. Get out the way. Get out the way. All right. So then I add 30, I get 120. Add 15, I get 135. Add 15, I get 150. We know this is 180, right? 210, 225, 240, 270. That makes sense, right? Add 30 more, 300, 315, 330. So by all means, you could memorize those. You're going to use them a lot. But do you see what I'm saying with the chunks? Big chunks are 30, little chunks are 15. Now you guys already have the radians in there, right? I'm going to show you all something that's going to blow your mind. What if I told you there's a lot to memorize on this, right? But you actually only need to know one quadrant. You only need to know one quadrant, okay? So we have our degrees, we have our radians. Let's label our points. What's this point over here going to be? Remember, a unit circle has a radius of 1. So that point is 1, 0, right? So this is why we're doing the unit circle. What's cosine of 0 degrees? 1. What's sine of 0 degrees? 0. Because if I have my unit circle, I know my sine and cosine of important parts. Let's do this top one up here. What's this point going to be? 0, 1. What's this point over here? Negative 1, 0, right? And down here we get 0, negative 1. Boom. That's a big part of the unit circle done. And just remember, this is a coordinate plane. This point is 0, 0, right? That point is 0, 0. Okay? All right. We're almost done. This lecture's almost done. It's not wild. Let's find this point right here. Now to do so, think about this. You don't have to draw it in, but if you want to. What kind of triangle is that? A right triangle. What else is it? It's a 30, 60, 90. So in a 30, 60, 90, if this is 1, that means I went up a half and over root 3 over 2. Okay? That's why we did that work with that special triangle before. So this point is root 3 over 2, 1/2. Now, let's say you don't want to make triangles and do this. What's bigger, root 3 over 2 or 1/2? Root 3 over 2 is bigger. Also, I'm going to erase the angles if that's okay with you, because I want to show you guys something. If you forget, if I draw that cross, what's it do to that line? Divides it in. half. So I know my y is a half. And my x does not cut it in half. So it's my root 3 over 2. 65, 70% of the unit circle is these 2 points in different orders and negative positives. So if you just know that if one's half, the other one's root 3 over 2. Okay? Trust me, once we get going, this is it's gonna kind of come together. All right, so I made a triangle. I came up with that point. Now for this one, what kind of triangle is this? It's a 45. 45. If this is 1, then this is root 2 over 2 from yesterday. Do you remember we did the triangle stuff? And this is root 2 over 2. So my point is root 2 over 2, root 2 over 2. So for my 45s, these are always equal, and they both have a bunch of 2's involved, right? So again, if you want to draw on the triangles where these are coming from, by all means, it is helpful. Just know we have a 45, a 30, and what's this last one right here? It's a 60. So what kind of triangle is this? 30, 60, 90. How do these two triangles relate? They're the same, just what am I flipping? My x and my y. So what's this point? 1/2 root 3 over 2. Now does that check out? Does that cut this in half? It does. Does this one cut it not in half? No, so it's root 3 over 2. So we got this is all stuff from yesterday, right? We're using our special triangles. Now, I'm going to knock your socks off. That's it. That's all the hard work. Now, this method is patented by me. I'm the only one I've ever seen use this method. There's probably someone else who does. It's not that genius. But think about this. I'm going to draw a rectangle in. Okay? What's going to be true about each one of these triangles? Are they all the same triangle? So what's going to be true about my x and my y? They're all going to be the same. The only thing that's going to change is my signs. Where are they negative, where are they positive? So over here, this one's root 3 over 2, 1/2. This one is root 3 over 2, 1/2. And this one is root 3 over 2, 1/2. But remember, this is 0, 0. So I went left, so it means that's negative, and I still went up, right? Here I went left and down, so they're both negative. And here, I'm going to rewrite that 3. I went right and then down, so my 1/2 is negative. My sign is negative. Do you guys see how I did that so quick? So you only need to know one. If I know this quadrant, I know every quadrant. Okay? And this is at the bottom of your paper, but I write this for myself. Every point in this upper quadrant is positive, positive, right? Every point in this quadrant is going to be negative, positive. Every point down here is negative, negative. And every point down here is positive, negative, right? Just remember it's a coordinate plane. Like we are still doing graph and stuff. Okay. What do you guys think I can do at this point then? Can I draw another box in? That's a square. So what's each point going to be off that square? Root 2 over 2. Root 2 over 2. Now, which one of these is negative, which is positive? That's my negative because I went left and I went up. Down here I get root 2 over 2, root 2 over 2, and they are both negative, right? And over here, I'm going to get root 2 over 2, root 2 over 2. Just my y is negative. So again, this looks really scary, but I assure you, even if you don't want to figure these out with triangles each time, could you just memorize those three? If you know those three, because these ones you can come up with, right? Like you can just look at, but if you memorize those three, you know every single point on this unit circle. Okay? And you're going to use them so much this year that honestly, a lot of them you're just going to have memorized. Like when you see sine of 30, you're going to know that's a half. You know what I mean? Because we do so much with them. Let's do one more box. So each point's going to be 1/2 3 or root 3 over 2, right? Negative in front. 1/2 root 3 over 2, both negative, and 1/2 root 3 over 2, just the y is negative. That's it. That's the unit circle filled out, right? Did anyone think it was going to take longer than that? I'm not kidding. When you guys go to take your AP test, I don't know yet exactly what it looks like, but it would probably behoove you to write that somewhere. Like it'd be a benefit to just quickly sketch it. You know what I mean? Because then you can refer back to it, and that's really helpful to have it. I'll put posters up on the wall. The one thing that I don't like, oopsie. The one thing I do want to show you guys that was given to you that I usually didn't, that's 0, 1, is how do you come up with the radians if you aren't given the radians? Could I take my angles and convert them into radians by doing pi over 180? You can, but there's a little bit quicker way, and I'll show you how I do the radians, how I derive them. You still have to know this first quadrant. This first one's pi over 6, because pi over 6 is the smallest, right? And we know that pi over 6 equates to 30 degrees, because that's an important one. This one's pi over 4, because it's 45 degrees. You know what I mean? A 45-degree triangle is pi over 4. That's how you remember it. And this one's pi over 3. So that one's pretty easy. This one's pi over 2. Because remember, it's 2 pi. So this is pi and 2 pi, right? So half of pi is pi over 2, right? So now how do I get these other quadrants? Use rectangles. So if this is pi over 6, this one is something over 6, this one is something over 6, and this one is something over 6. That rectangle not only gives you the same x and y, my radians all have the same denominator. And then what I would do is, what's 1/6 minus pi? 5/6. So it's 5 pi over 6. Because it's 1 less, right? It's 1/6 less. This is 1/6 more. So it'd be 7 pi over 6. And this is 1/6 less than 2 pi. So it's 11 pi over 6. You guys see how I did that? Because each of these is a 6, and each little one is 12, actually. Each little one's a 12, but I don't do it that way. So like if that's pi over 4, this one's something over 4, right? What's 1/4 minus 1? 3/4. What's 1/4 plus 1? 5/4. And then what's 1/4 minus 2? 7/4, right? 8/4. You guys see what I'm doing here? Or no? So this is how I do it. You know, I mean, how I derive the pies, because you feel it too. So then my pi over 3 is going to be, what's this one going to be? Well, you guys had 2 pi over 3, right? Because it's 1 minus a third. 1 plus a third. Four pi over 3, right? And then this one is 2 minus a third, which is 5 pi over 3. There's other patterns too kids have used in my class, like, do you notice each of these is one less? You know what I mean? Each of these is one more. Does that make sense? Like the top is one more. Then it breaks down over here. I'd already kind of know math. But that's it. That's the unit circle. How do you use it? Good question. Ooh, what's the bottom asking for? Oh, let's see if I can do this without it. So the bottom is asking you in quadrant 1. Do you guys remember your quadrants? 1, 2, 3, 4. Did you guys ever wonder in algebra why isn't quadrant 1, quadrant 2, quadrant 3, and quadrant 4? Did you guys ever wonder that? It's because angles, right? You start in quadrant 1, and if you use the angle, you end up in quadrant 4. Okay. So in quadrant 1, does it want sine? What's my sign going to be? Is it positive or negative? In quadrant 1, what's my y value? Is it positive or negative? Positive. What's cosine? So then what's tan? Yeah, because I'm dividing those, right? Oh no. Look at me using all whiteboard today. All for my friend DA. What about quadrant 2? What's sine in quadrant 2? Positive. What's cosine? Negative. So what's tangent going to be? Negative, because you're dividing your sine and your cosine. What about 3? It's negative, negative, positive, right? Because a negative divided by negative is positive. Which makes sense. What are the slope of these lines in the third quadrant? They are all positive slopes. Positive slopes. So tangent's positive, tangent's positive. What are the slopes of the lines on these ones? Negative. So tangent's going to be negative. I don't know if that helps, but quadrant 4, what do we got? Sine is negative, cosine's positive, so tangent's negative. Okay? So why do we use the units? What's the point of this? So far, Mr. Twillier, you've told me all this stuff, and it kind of like, it's not too as scary as I originally thought. But why? No, I'm just kidding. Why? Now you can do math really fast without a calculator. Like, if I asked you what sine of 120 degrees, I can use my unit circle, right? This is my 120, right? When I look at my unit circle, I don't know if that's on there. When I go to 120 degrees, what's my y coordinate? 3 pi over, or root 3 over 2, right? See how quick that was? Now, it may seem goofy to have to do that, but when we do problems where you have to do like 8 of these in one problem, it's a lot quicker just to look at a unit circle and be like, that's that, that's that, that's that. Does that make sense? Or what's tangent of 11 pi over 6? Well, tangent is my y over x, right? So I go to 11 pi over 6. My y is negative a half. My x is root 3 over 2, right? So I got negative 1 over root 3, which you guys know how to do this really quick now, right? Negative root 3 over 3. So that's what we're going to use this for, okay? The end.
I started writing stuff on my